Okay, so what we're going to do now is we are going to use similar triangles and right triangles to find the lengths of altitudes and sides and hypotenuses. So we're going to go through and do this with a table and then learn a nice happy rule that's pretty easy that works with everything. So the first thing we're going to do is we're going to follow the instructions here on number 2, and we're going to label a whole bunch of stuff. So it says, here's a right triangle ABC. Draw the altitude BD. Okay, so here's BD, and that's going to be my altitude. And then it says label segment AD is X. I can do that. DC, so this part here, is Y. And BD is H. So we're going to label those. And then down here, we are going to compare the lengths of corresponding sides of the similar triangles that exist here. So first, I'm going to have you change this table. And I apologize, but I really like the new way that we want to label this. So I want you to change this from shorter leg over hypotenuse just to shorter leg. Change this just to longer leg. And I want you to change this entirely to just hypotenuse. So what we're going to do is we're going to compare the short leg, long leg, and hypotenuse of the 3 separate triangles. I also want you to label these as triangle ABC is the large triangle, the biggest one. ADB here is the small triangle. And BDC is the medium triangle. Okay? So what we're going to do is we're going to compare everything here. So the short leg of triangle ABC, here's ABC. The short leg of ABC is 5. It's this guy. The long leg of ABC is this guy. And the hypotenuse of ABC is from A to C, that's 13. So in my first similar triangle, I know all 3 sides, they're 5, 12, and 13. So that means in small triangle ADB, the short side of this triangle is X. The longer leg, remember legs make up the right angle, the longer leg is H. And the hypotenuse of the tiny triangle is 5, which shows me that the short leg of the big triangle actually makes the hypotenuse of the tiny one. And that's okay. Now, medium triangle BDC, we're going to do the same thing. So BDC has a short leg of H, a long leg from D to C, which we called Y, and a hypotenuse of 12. How is this helpful? This right here is a big table of proportions. If I have similar triangles, which we established in class, if I have similar triangles, as long as I compare corresponding sides, I can make proportions. Now, don't do this. I'm just going to highlight haphazardly for a second here. I can make a proportion between any pair of things in the same row and column. So I can make the proportion 5 over H equals 12 over, 5 over X equals 12 over H. I could make the proportion H over Y equals 5 over 12. I could make the proportion 12 over H equals 13 over 5. I could make the proportion 5 over H equals 12 over Y. As long as I compare things within the same row and column, I can make any proportion I want. Now, I've obviously just scribbled all over that, so let me try to make my scribbles go away here. So, what I have here is I want to set up some proportions, and ignore the writing because we're going to go back and do this from scratch. I want to make some proportions.